Hey everyone, welcome back to my series on OAuth 2.0 and a code walkthrough of my implementation of it called OAuth 2.0 bin. In this third episode, we are finally going to be taking a look at the very first flow of the protocol called Authorization Code. So the Authorization Code flow is the most commonly used flow out of the four that are described in the RFC. It's also the most complex among the four. It's not complex in an absolute sense. It's just a bit more involved than the other three. It's also the most flexible among the four flows because you can add stuff on top of it to make it work better. Stuff like OpenID Connect. It's best suited for server-side applications. Now, the reason for this is that authorization code deals with certain parameters which must be kept private. They should be stored securely, and you cannot reveal them to your clients, to your public clients like websites or through your mobile apps. So a server is the best choice for something like that. This authorization code, along with the resource owner password credentials flow, is the second flow in OAuth 2.0, which supports refresh tokens. And finally, it's a three-step process. This entire flow consists of three well-defined steps, and we'll be taking a look at each of them in a lot of depth in this video. So you might recall this example from the previous video, in which a user was trying to buy a few t-shirts on this t-shirt store, and they were trying to log in into this t-shirt store using a third-party service. And we took the example of Google in that video, and we'll stick to the same example in this video to keep things familiar. So as I said, it's a three-step process. So let's look at each of these steps one by one. The very first step is to present the user with an authorization screen and to seek authorization from them. So when you click on those, sign in with Google. Oops, I hope that's visible now. So yeah, present authorization screen to user and seek authorization. So when you click on those, sign in with Google, sign in with Facebook, GitHub, Microsoft, whatever, on those buttons, you're taken to their website, and then you see that screen where you basically allow whatever the t-shirt store in this example to access your information from Google, right? So the first step is to do that, and in order to do that, it's just a simple GET request. Your browser sends a GET request when you click on those buttons, and this URL to which the request is sent is called the authorization URL. This is predefined, this is fixed, and yeah, so this URL is served by this authorization server. Okay, so this authorization server is going to have one of these authorization endpoints, if you will. Since this is a GET request, and well, it cannot really have a body, so you need to encode certain parameters into the URL itself. So these are the query parameters that are necessary for this request to succeed. So you need response type equals code. This basically tells the authorization server that, hey, this is a request for the authorization code flow grant. If you there are this code value could be something like token if you're using the implicit flow grant, implicit grant flow, I'm sorry. And this has to be exactly like this. Response type equals code. This is defined in the RFC. The next is client ID equals something. So before the t-shirt store, when they are building their website, they would have to, and they when they decide that, hey, we want to let our users sign in with this third-party service, they would have to actually code all of that up. They would have to develop that that whole procedure, and in order to therefore in our example, in order to sign in with Google, they would have to first sign up for this service themselves, and when they do that, Google would give them a unique identifier which is called the client ID, and so this would be unique to the t-shirt store. And when you this needs to be included in the request so that the authorization server can identify from which OAuth client. We talked about OAuth clients in the previous video, which OAuth client this request is coming from, so the authorization server can know that. And finally, we have this redirect URI. You might have noticed that when you actually you will be on this t-shirt store, you click on that sign in with Google button, you'll be taken to Google's authorization page. You maybe accept the terms of authorization, and then you're taken back to the t-shirt store website, right? So this redirect URI basically tells the authorization server where to redirect you back to after the authorization is complete. Okay, so when you send this GET request, you basically get the authorization screen back as a response. So why don't we try this out in the browser? So I've opened up OAuth 2 bin. Now this URL is not actually valid at the moment because I haven't bought this domain name yet. So right now we're just running on Heroku, and so yeah, you can check this out as well, auth2bin.herokuapp.com. We checked this out in the previous video, and we are working with the authorization code flow. So if you click on that, it will expand and show you all of the parameters that are necessary to complete the flow, and you'll see our authorization URL here. So I'm just going to copy that, and let's try to make this request. Okay, let's see how stuff happens behind the scenes. So we have response type equals code, and what else do we have? We have client ID equals now if this were, you know, a real OAuth 2.0 server, we would issue client IDs, you know, we would issue unique client IDs to each of our clients. But this is OAuth 2 bin is a mock server. It's meant to you know, it's just meant for testing. So we have just one client ID for everyone, and it's client ID written in camel case. And finally, we need a redirect URI. Now in the RFC, redirect URI is actually optional. You need a response type and client ID are or did I say client ID is optional? Okay, I kind of got lost there for a second, but yeah, so response type and client ID are mandatory, but redirect URI is optional. So let's where can we redirect to? We don't actually have this t.in, this t-shirt store website, so we'll just redirect to some dummy website. Let's say we redirect to YouTube. Okay, hit enter. I hope this was correct. Yeah, we see OAuth 2 bin's authorization screen, and so yeah, step 1 is complete. We have shown the user the authorization screen. So this was the first step and the first request in this whole flow. Now let's jump into the code and see how this actually works behind the scenes. Okay, so the execution of the whole project starts from this main.go file, and it just basically creates a new OAuth 2 server. You can, it's a struct, and we have some methods that we have implemented for it. Okay, and finally we start the server. So the main.go file is pretty simple. Okay, we just start the server, and this is this s.setuproots. This method is the most important method in this whole project, I would say. So setuproots actually sets up the routes, the endpoints, and their respective handlers. Okay, so initially we set up the static file server for, you know, serving all of the static assets like HTML, CSS, and JavaScript and stuff like that. But the actual handlers for the dynamic requests, we do that here, and I'm using this s.chain this chain common middleware method in order to do this, so that we can so along with the handler we can also attach some middleware before it. And it's called chain common middleware because we attach some middleware. You can see this method is implemented up here, and we attach the rate limiter that I talked about in the previous video, and I also have another 404 middleware, which basically if you try to access a route which is not defined, it just shows a 404 page. So yeah, so we have these two middlewares which are attached to all the routes. So I just created this simple utility method to attach them to all the requests, and if you have any additional middleware, you can specify that here. You know, in this case you can see this post form validator middleware that we're using here, and we'll take a look at this endpoint soon. But right now let's look at this /authorize, because that's what we sent a request to, right? /authorize. See, so the /authorize endpoint is handled. By the way, before we get there, this we started from main.go. This server is defined in this OAuth 2 package within the server sub package in the server.go file. Okay, and these handlers for these requests are defined in root handlers, and root handlers is also in this server package. So the dispatch, or the flow of the code is somewhat like this. So we start from sorry, we start from main.go, then server.go, and the request comes in. When the requests start coming in, they first come here, and then they are dispatched to their respective root handlers. So the handler, the specific handlers, request handlers for a certain route, which are all all of them reside in root handlers. And then root handlers perform some basic rudimentary checks. They check the parameters, they check some bodies and the method, the method of the request and stuff like that. And based on the information that they see in the request, they dispatch the request further to these individual handlers. These handlers actually control the they are the handlers for the respective flows in the protocol. Okay, so we'll be taking a look at auth code handler obviously in this video. So let me just quickly close that so that keep it neat and tidy. Okay, so server.go, it dispatches it dispatches all requests to /authorize to handle auth. So let's take a look at handle auth. The first thing it does is it just checks if it's a GET request. If it's not, we send an HTTP 405, which is method not allowed. And if we send a GET request, okay, so it came here, we did not, that worked. Next, we take a look at the params, because that's what we are interested in, right? We want to look at this stuff. So we parse all of those parameters and we check, and as I said, response type and client ID are mandatory as per the RFC, so they absolutely have to be there. If they are not, we say it's a bad request, HTTP 400. If they are there, then we take a look at response type. We want to first check that what flow we are using. So if it says response type, and if the value for the key response type is code, then we can be sure that it's an authorization code request. Okay, if it's token, we would be talking about the implicit flow grant. Why do I keep saying implicit flow grant? I think it's implicit grant flow. Okay, if it's code, if it's authorization code, then we further dispatch the request to this handle auth code auth, which has a very weird name, but this function resides in auth code handler. Okay, now this might seem weird, but there's actually a hierarchy that's prevalent in this name. So it's obviously a handler, so we have handle at the very beginning. It's a handler for the authorization code flow, so we can deduce that from the name. And then finally, it handles the authorization request. Okay, it handles the request to the /authorize endpoint, and that's the reason we have this last part. If you take a look at some of the other functions in this file, we have handle auth code token, which would be the token request, and we'll take a look at that in a few moments. But right now, let's take a look at handle auth code auth. So we again take a look at the client ID. Now we have verified that, okay, this is an authorization code request. Now we are interested in this client ID. We want to check if this is a valid client ID. Now if this was a real OAuth 2 server, you would probably do a database lookup and see if this client ID is legitimate. But this is a mock server. We only have one client ID. We have a universal client ID for all requests, so we just check if it's the same as that. Now this server config.authcodeconfig.client ID, this would actually contain this value. This is you can actually change these values using these configuration files. Okay, these configuration files, see, and then they are loaded up. You just pass the path to the file here, and the server, when you create the new server, it will actually load these things up. See the configuration, and that's what we are taking a look at here. The server configuration, in that we have the authorization code configuration, and in that we are looking at the client ID for authorization code. You can take a look at this this entire thing in this config package. We have this config.go file, which this is the configuration for the entire server, which itself has some more structure objects inside of it. So we have authorization code config, we have client ID, client 600. I hope that makes some sense at least. So if the client IDs match, if the request client ID and the one that we have defined here match, we present the user with an authorization screen. And this is a utility method that I've just written here. I don't know if this is such a good idea to write it in utils.go, but that's what we have here. So this basically just executes some templates. So we have defined this as a template in the in the public templates file. So we have this auth screen file, authorization screen. It executes this template, and this is what you get. So a fun little thing here, if you refresh this, you'll see these change. Okay, and they are completely they're just fun. Okay, they don't make any sense, they're completely nonsensical, but they keep changing. We have these fun list of scope strings. These are the scopes. If this was an actual server, you would see maybe you're logging into Google, the scope would be like, this application wants to access your email ID, they want to take a look at your contacts and stuff like that. But we don't have any of that. This is a mock server, so we have these fun scope strings, and every time you call this present auth screen function, it just randomly selects 3 out of this list. Okay, just to keep it fun. Okay, so I think that's done here. So the request would be complete here, and the user will see this. So let's jump back to the presentation. Okay, the next thing we do is we receive authorization grant from the authorization endpoint. Now, before we do that, what happens is the user would click on this accept button, and well, the thing that what we need now is proof that the user actually was actually authorized the t-shirt store to access their information from Google, right? If in our example that would be the case. So when the user actually clicks on this accept button, a request is actually sent to the authorization server telling that, hey, the user's response was accept. Okay, and well, since the user accepted the terms of our authorization, the authorization terms, we would like some proof of it. Okay, just tell us, just give us some, like a little, I don't know, something to tell us that, okay, well, the user did accept our authorization terms. And well, that's what the server does. It gives you back this authorization code. Okay, now let me I'll sort of explain what's happening here, but this is the most important part here. The server will give you back a little string, which is called the authorization grant, which is a proof of the fact that the authorization was indeed done. The user did authorize this OAuth client to access their information from Google. Okay, so we need this proof. This is just proof of that. Okay, now the way this is done is that once you click on this accept button, you want to be redirected back to the t-shirt store, right? So what the server would actually do is it will send an HTTP 303 request response, which means it's a redirect response. Okay, this tells the browser that, hey, I have in this in the response headers, you want to check this location header, and you want to redirect the user to the URL pointed to by this location header. So when the browser sees this 303 response, it's going to look at this location header, which is going to be set by the server while generating the response, and in the location header you'll see this URL. Okay, and in that URL you'll have this code equals auth grant, whatever the authorization grant is. It will be embedded in the URL itself. Okay, so and by the way, this has to be a post request. Okay, at least in OAuth 2 bin, this has to be a post request. This isn't really detailed in the RFC itself, if I recall correctly. It's been a while since I worked on this project, but I don't think this is actually mentioned in the RFC. So you can do this process any way you want, but this is how I'm doing it. It's pretty simple. It's just a post request, and then you're redirected to this redirect URI. Okay, so let's click on accept and see what happens. Okay, our redirect URI in this case is YouTube, so we should be redirected to YouTube, and we should receive this authorization grant in the URL. Okay, and yep, see, YouTube is loading up, and we have this authorization grant. So cool, we've even completed the second step. So let's quickly take a look at how this works in OAuth 2 bin. So again, we'll start at setup roots. We have the /response endpoint because, well, that's the URL that we are going for. That's the endpoint we are going for, which is also this endpoint. This would be the second endpoint on the on the authorization server. Oops, why do I keep clicking on this? I'm just giving away my presentations, spoilers. Okay, so yeah, this would be the second endpoint on this authorization server. The first one was /authorize. This is the second one that we have. So the /response endpoint, since we are sending a post request, and oh, by the way, I should mention that since this is a post request, these parameters are not actually embedded in the request itself. Okay, these are part of the request's body, unlike in the first request where they were part of the URL itself. They are part of the body, and this is the form URL encoded content type. So since it's a post request with a form, we want to check this happens a couple of times. We have these kind of requests a couple of times in this project. So I created this middleware, which we have attached to this endpoint. Okay, so this will actually execute first. It will verify if the request is valid. So it just validates if it's a post request with this form URL encoded body, the content type. So yeah, we check the method, we check the content type. If it matches, sure, good enough, we'll proceed to the handler. Otherwise we present some errors. Okay, so it's fairly simple. The handler for this this endpoint is handle response, and this again resides in root handlers. Now actually we since we use this let's go back. Since we use this authorization grant page for authorization code and the implicit grant flow, there's a hidden form field which tells which flow we are using. Okay, so if you see, the flow is 1 here, which indicates authorization code. This is actually set up I think while we present the authorization screen. So yeah, it also accepts the flow number here, and it sets it up here. So the reason for that is when we get this response back from the browser, we want to check what flow we were actually using, what flow is sending us back this response. So here we would see 1, again the value 1, because it was part of the form, and it will be sent back as a parameter of the request. Yeah. So we'll check the flow. This will tell us that, hey, it's an authorization code request. If it's 2, it would be an implicit grant flow. So we have the flow. Then we take a look at the response, which is which would be accept or cancel, and then we take a look at the redirect URI. We grab that, and finally we check. We see if the user did indeed accept the terms of authorization. We look at what flow we are using. If it's the authorization code flow, now we just want to redirect the user to this redirect URI, but we also want to attach a new authorization code, authorization grant, I'm sorry, and we generate that grant using our cache. And this is sort of like the store in OAuth 2 bin, and I'm gonna have a separate episode on this entire cache package, which basically is just the Redis stuff. So we just store all of the our tokens and authorization grants, and we generate them, and how we generate them and how we manage all of that. All of that is done by the cache. So we just generate an authorization code grant. This is just going to be a long random string. Okay, we attach that to the URL, and finally we redirect the user to that redirect URI. Okay, so that's it for the second step. Let's move on to the final step, which is receive an access token from the token endpoint. Now we have this this authorization grant. Now we can use this authorization grant to actually fetch an access token so that we can use the API. Okay. So for instance, the t-shirt store, we talked about this in the previous video. So the t-shirt store will exchange this sort of this authorization grant and receive an access token back as a response, and then it can start making requests to the API. Okay, now it's again going to be a post request that the t-shirt store would have to send. By the way, the requests that were being sent so far, all of that happened in the browser, okay? But now this final request is actually going to be sent by the t-shirt store's server. The reason for that is this client secret that I talked about. Okay, this is something that the authorization server would the authorization server would give to this t-shirt store when they initially sign up for this whole thing. Okay, so this has to be kept secret. This is what I was talking about in the introductory slide. This cannot be exposed to the public. So this request is always made by the t-shirt store's servers. This won't be exposed to the client in any way. So we send a request to this token URL. Okay, it's a post request, and it's again that form URL encoded request, and so all of this is going to be part of the body. So let's take a look at each of these parameters one by one. We have grant type equals authorization code. This is another this is just mandatory. This tells the the token endpoint that, hey, we're looking for we're looking at an authorization code request. I keep revealing my slides, okay? I give away spoilers. Then we mentioned the authorization code, the authorization code grant that we received in the previous step, because now it's like, hey, so this is proof that the authorization indeed happened. This is the reason we have that. So we add that to the URL here, to the body here. Then we have the redirect URI. This needs to be mentioned. This is kind of a I don't think this is let's not talk about this at the moment. This is a bit complex. Maybe I'll get to it in the code. Let's see, or maybe I'll talk about this in the cache video, the next one probably. We mentioned our client ID so that the authorization server, the token endpoint of it, knows who is sending this request, and we also mentioned the client secret. Okay, so pretty straightforward. And if all of this checks out, the server will give us an access token. We finally have an access token. So yeah, it's going to be, it's mostly in JSON, stuff like this. You get the actual access token itself. You also get a refresh token. We'll talk about that very soon. And all access tokens, by the way, have a certain lifetime. Okay, they expire after a certain period of time, and that period of time is indicated here. So this is so for example, this access token would have a lifetime of 3600 seconds, which is an hour. So let's create another one of these. Let's get a new authorization grant, and we'll use this authorization grant to actually fetch a token. So now for this, since we are sending a post request, we'll need an API client, a REST API client. I'm using Nightingale. You can use Postman, Insomnia. I actually used Insomnia in the previous video. It doesn't matter. Let's create a new request. Okay, it's going to be a post request, and you need the URL that you need as the access token URL. Okay, and we need to add stuff to the body. We are using the form URL encoded content type. The first thing we need is this grant type equals authorization code. Grant type authorization code. Next we have the code itself, the authorization grant that we received. Let's just grab this from here. We have the redirect URI. We had used youtube.com, so we'll stick to that. youtube.com. And finally we have the client ID and the client secret, right? Client ID is client ID in camel case, and the client secret is also client secret in camel case for OAuth 2 bin. It's a mock server. We don't give out individual of the individual client IDs and client secrets to our users. We can just use the same thing. Secret. All right, I think this should work. If let's quickly send this request. Let's see if this works. And yes, it has indeed worked. We have received our access token. It's a very long access token. We receive a refresh token, and this token expires in 3600 seconds. So now we can start using this token to make API requests. Okay, so let's jump into the code and see how this would work. It's all, again, it's pretty straightforward. We send a request to the /token endpoint. We're sending a post request with this. Form URL encoded content type. So again, we are going to make use of this post form validator middleware. Once that checks out, the request is dispatched to this handle token handler. In root handlers, it will read the entire body. Yep. Now in this, since this is a backend request, okay, since this request, as I said, would be sent by the server, we don't actually present it with HTML responses. We send JSON errors because it's an API. Okay, it's an API call, sort of an API call. It won't be made by the user. It would be made programmatically by the server. So we send JSON back as a response in case something goes wrong. Then we parse all of those parameters. We read the body, and then we convert, this entire thing. We read it, and we parse it into key value pairs. And we absolutely need client ID and client secret. These are mandatory. Actually, there's a little variation to this. What you can in fact do is, if you don't want to mention them in the form URL encoded body, you can set them in the authorization header, and you can sort of concatenate them together and do a base 64 encoding of them and use that as your authorization header. So if we don't actually find them in the body, we will look for them in the basic in the authorization header. Okay, we look at this authorization header and we'll try to pass them from there. All right, then we finally take a look at the grant type. This tells us its authorization code. If it's something else, it's different for different flows. So if it's authorization code, we'll forward the request to handle auth code token. I talked about this. So it's a handler for the authorization code flow, and it's a handler for the authorization code flows token endpoint. So we check if the mandatory parameters are present in the request. So we absolutely need client ID, grant type, code. I think client secret is optional. I'm not sure. I'll have to check the RFC. It's been a while since I've worked on this. I should have known better, actually. But yeah, we look for those. If they're not there, we send a JSON response, an error. And if everything checks out, we generate a new authorization code token. So this, even though we call it a token, we actually get back this entire thing. Okay, so you don't just get this access token, you also get back a refresh token with it. So the cache will generate all of that, and we, as I said, we'll take a look at this in that respective videos, which I think should be the next one. So we generate a new token, we serialize it to JSON, set the content type, and we just return it back as a response. All right, so yeah, this was the response. It's JSON response. Cool. Next, let's take a look at how a request would look like. We have the access token. How would you send a request to the API? So we don't actually have an API endpoint at the moment, but it would probably be something like this, auth2.org/API/ maybe you want to check out a user. If the t-shirt store was looking at the Google API, maybe they have something like this, apis.google.com/something, and they maybe want to check out this user, and then you send a query parameter or something, this to filter out the request. So maybe you want to check out the user with a username of Rohit, which is my name, and the access token, you would need to somehow send the access token to them, right, to verify that you are indeed authorized to make this request. So you would set this authorization header in the request with a bearer type of a header, a bearer type of a token, and you would base 64 encode your authorization, your access token, and you would paste the base 64. Again, you would paste, you would add that base 64 encoded access token here. So this is actually a base 64 encoding of this access token, T token. Okay, so Once you send this, if this authorization checks out and if they find this user, you would get back a response, something like this. This is just an example. Okay, so yeah, my name. Yeah, you would get back a JSON response. JSON is pretty common, right? Now, as I said, access tokens have a fixed lifetime, and if your token expires, you can no longer make these RESTful requests to the API. And in that case, we have actually handed you this refresh token, right? So what you can actually do, oops, anyway, what you can do is you can, instead of going through this entire authorization process, because that's tedious for the user to, authorize the application again. And if you have to do this every hour, this token only had a lifetime of an hour, it would be really annoying. So what you do is, what the t-shirt store would actually do is it will use the refresh token to generate a new access token. And the way this works is it will send a refresh request. It's going to be a post request to the token endpoint again, but this time the grant type is going to be refresh token. Okay, and you would mention the refresh token that you received in the original token request. You would mention your client ID, your client secret, and if everything checks out, the authorization server will hand you over a new access token that you can use. This is also going to have another lifetime, a fixed lifetime again. So you'll still have the same refresh token as before. So if this one expires, if this access token expires, you can just use the refresh token to generate more tokens. And that's basically it. Let's quickly take a look at the code for this. This is not really that different. So again, we are sending a request to /token, and it would be dispatched to handle token, and we looked at all of this, but now the grant type is different, right? We have previously this was authorization code, now it's refresh token. So we'll just take a look at this refresh token logic. So all tokens in auth to bin are 72 characters in length. So we first check that. If their length is not 72, then we definitely have a bogus refresh token that we are seeing. We're basically verifying the refresh token, and then we just check the refresh token, and we handle that, and we give out a new one. So that's it for this video. I hope you found this useful. I think we skimmed over the whole refresh token logic thing a bit too fast, but you would need some more context to how the tokens are actually stored under the hood in order to make more sense of the code that you saw right now. So after we do the whole cache and token store video, we'll talk about refresh tokens in a bit more depth, probably in that video itself. So stay tuned for that. If you found this useful, please consider subscribing, and I'll see you next time. Thank you. Bye bye.